Chapter 3, Section 1 in our textbook is quite a big section. I split this into 4 different pieces. Those will be 4 different videos. We'll just be doing part 1 in this video, and that is making sure we understand what linear functions are. So a linear function is an equation that can be written in this form. ax plus by equals c. This is called standard form. We'll talk more about that on part 2 of the lesson, but I do want to make sure it's understood that a, b, and c are numbers. So you might see something like 4x minus 2y equals 7, because different equations will have different numbers, but the point is the a, the b, and the c are really just coefficients or constants. It's only x and y that are actual variables. And this is an important phrase, that it can be written in that form. You don't have to be written in that form to be linear. The point is, if it can be rearranged to be in this form, then it is linear. So honestly, I have found it's easier to tell you what makes it not linear, since it can show up in forms other than this. So there's 4 ways you can look for that tell you, oh, no, it's not a linear function. If there are exponents, obviously there's always technically an exponent. We don't write it, but there's an understood 1 right here, that's x to the first. There's an understood 1 right here, that's y to the first. That's of course fine. But when we have an exponent like a squared, or a cubed, or a squared, forgive me, and it doesn't matter if it's on x or y or both, any exponent on a variable means it's not linear. And I don't think I've said this yet. Linear, the key part of that word is line. Linear means it would form a straight line on a graph, no curving. Okay, also, it's not linear if there are no variables in the equation at all. Now 3 plus 4 equals 7 is true, but it's not a linear equation. That won't form any line because there's no variable. You have to have a variable. You can have just one variable. It could be just an x or just a y shows up. But if there's none at all, it's not a linear equation. Now this won't show up much, honestly, number 2, but I want to be official and tell you all the things. Also, if variables are being multiplied together, that's not going to be linear either. So this right here and this right here make these two not linear because we have variables being multiplied together. Last thing that tells you no it's not is that if a variable is in a denominator. Just a reminder, the denominator is the bottom of the fraction. So this variable being in the denominator, the 2 doesn't matter, I just can't circle that small. But the y being in the denominator is the problem there. But I want to make sure something is clear. I didn't say no fractions. Fractions can be in there. I could have 8/3 x plus y equals 10. That's fine. That's linear because the variable is not in the denominator. I could also have like x over 3 minus 2y equals 10. There is a fraction, but x isn't in the bottom of the fraction. So that is linear. That's fine. It's only a problem if the variable is in the bottom of the fraction. Fractions are allowed. Variables just are not allowed to be in the bottom of it. So this is the last part, but it's 12 questions. We're just going to say, are they linear or not? So the easiest thing to do is to just say, I assume it is linear unless one of these 4 things shows up. So you just kind of go through a mental checklist and think, do I see any of these issues? So as I look at number 1, there's no exponents, no variables being multiplied together, no variables in the denominator, but there are variables, so yes, this is linear. Number 2, I could run through the same routine. No exponents, nothing being multiplied, no variables being multiplied or in the denominator, and there is a variable. Now there's only one variable, that's fine. It's okay if there's just one y or just an x and not both. We just have to make sure there's at least one of them. So this is also linear. This one is also linear. You can check through all of them. It doesn't cause any problems. So these are all yes. Now here's where the fun begins. As we go through, we say, okay, there's no exponents. There are variables, but number 3 issue. Variables being multiplied together. That's a problem. That means it is not linear. Okay, I'd encourage you to pause and then go through these and see if you can figure out which are yes and which are no. Five is yes. None of the 4 problems that, none of the 4 issues listed up here shows up in number 5. 6 is not linear because we have a variable. It's not allowed. 7's linear. We do just have an x and not a y, but that's fine. You're allowed to have just one, but you're not allowed to have none. So this is linear. Number 2, we have a fraction, but the variable's not in the denominator, so that's okay. This one's also linear. Okay, 9, we have a fraction, but the variable is in the denominator, so that means it's not linear. Okay, 10's got 2 things that would keep it from being linear, the exponent and the variables being multiplied, so it's no. Okay, that has variables being multiplied together, so it's also a no. And finally, this throws people off. They're like, wait a minute, y shows up twice. That's true, but there's no rule against that. Just think through the rules. Are there any exponents? No. Are there variables? Yes. Are any variables being multiplied together? No. Are there any variables in the denominator? So this is linear. Now you don't have to do any work on this. You can just look at this and say, yes, it's linear. But I do want to show you, if it's helpful, how the fact that there being more than one y term is okay. Because I could, if I wanted to, actually just subtract y from both sides and rewrite this as 6x minus 3y equals 8, which is in that form we talked about. So this thing can be written in standard form. So it is linear. So don't get thrown off if a variable shows up more than once. As long as it's not being multiplied by another variable and it's not in the denominator, that is okay.